Hello, everyone. Welcome. So glad you are able to take the time to join us today. For those of you that are here virtually, if you are catching up and joining us for the recording afterwards, we're also grateful, and I'm very excited to introduce our speakers today and to just to learn from their experience and their expertise around how you might bring robotics into the classroom. And so I would like to take a moment to, okay, thank you. I'm so sorry. It looks like I've got some connection issues. Not a good sign as the host, right? I'm glad you were here. I wanted to start our session today with a landing to acknowledge that we are coming to you today from on Treaty 7. And our gathering is taking place on the traditional lands across the province of Alberta, but home to many diverse Indigenous, Métis, and Inuit peoples. Spanning generations, acknowledgement of the land is a traditional custom of Indigenous peoples and an important part in reconciliation. It gives voice to the authentic history of the land and its original people. It's really important for us to take this moment to acknowledge this story and to take a leadership role as educators to move forward toward reconciliation and to understanding our shared history. So thank you for that. I would like to turn it over to our guests today, Samir Haji, Christopher McDonald, and Ryan Unterschultz. So thank you so much for being here.
Thank you, Cheryl. So if you read our bios, we're a trio of, we have some commonalities and some commonalities that have brought us together, but we come from different backgrounds in our professions, which made it quite exciting to work together. So I'm just going to play this video, and by the end of the session, you'll be able to do this with these robots. And no, I'm just kidding. But anyway, I think it's a cool video to watch. We'll watch a little bit of it just to get started. Hopefully it runs. All right. Okay.
That's a good start.
It's I'll not talk too long about it. It's a video with they programmed robots to dance, choreograph and dance to a certain songs, and it's quite incredible. I'll try to, if you would like, I'll share that with you. It's not allowing me to advance the slides either. Okay, just a sec. Go that way. All right, so we want to, we understand robotics brings a range of excitement and concern. So we thought about our hopes, questions, curiosity, struggles, and dreams that we have with robotics. So we wanted you to think about the expectations you have for today's session. And in our chat, if you could just, if you would like to, and you don't have to, just write down what a hope is for you to gain from this session today. What do you hope to gain, or what would you like to learn, or what do what would you like to come out of this with? So if you can put that in the chat, that would be appreciated. We'll take a look at it and come back to it and see if hopefully we can address many of your hopes. So we have some idea-specific activities for middle school, tools to better teach robotics, other than just physical science. Now that Mindstorm is discontinued, we'll definitely address that one. How to start a robotics program, that is one of our biggest goals today, so that's awesome. High school level resources, we can refer to that as well. I think we can address many of your concerns. We'll keep the chat open for you to post any more comments on that, please do. And we'll see if we can kind of get to all those topics and issues and concerns and excitements you have. The next question I have for you is, what skills do children apply when learning robotics? What do you think? I have a Menti set up here. It's going to turn into a word cloud. to see what kind of skills you think children apply when learning robotics. This is something that Samir will return to and see what his research has shown and compared to what you observe and believe to be important. So if you want to go to menti.com and type in that code, you can try the QR code. It is a screenshot, so but it still should work. There's a link connected to that. So at menti.com, write in that code, and then you can write. We'll give you about 2 or 3 minutes to just write down some skills you think that children apply when learning robotics.
Ryan, can you please call out the code for us?
Yep, 69795737.
Thank you. I just put it in the chat.
Thank you. So yeah, it could be any kind of skill sets that you think children are using when they're learning robotics or using robots. And we'll come back to that and take a look at how this aligned with some of the research. That's going to be open for a while now, but I'm going to move on to our next slide, and you can type in that one or go to that whenever you would like. All right, Samir.
Hi, everyone. My name is Samir Haji. I wanted to give some context, actually, around why we're even talking about robotics in particular. And I think this part of the conversation will just start by talking about what's known as the fourth industrial revolution. It's probably something that you guys have heard about or are familiar with. But essentially, it's this convolution of all these various technologies that you see there on the right. Autonomous robots, big data, et cetera, et cetera. All of these technologies are evolving at a rapid pace. And I think we're starting to feel that now, particularly as we all hear the buzz around ChatGPT and generative AI. We really are in the midst of this fourth industrial revolution. And we've gone through previous revolutions, as you can see there. This is the fourth iteration, I guess, or Industry 4.0, as some people call it. But it just feels different this time. It is moving at an unprecedented speed. And we've got newer and better, faster gadgets every year, generative AI, as I mentioned, the list goes on and on. And at the same time, the technologies that make up this 4.0, Industry 4.0 is really influencing every aspect of human existence, and frankly, in unpredictable ways, mainly because these technologies are not only changing industries and the human existence on their own, they're influencing each other, making the entire ecosystem quite unpredictable. Next slide.
That's right.
And if you ask folks in industry, how do you feel about these various technologies? Are they transforming your industry? 71 to 87% of the people surveyed have said that either the industry is already transformed or will transform within the next 5 years. And I guess the scary thing for us as educators is that some people are saying that 85% of the jobs in 2030 haven't even been invented yet. Next slide. So how do we prepare our kids for the future? And this is a study done by the World Economic Forum that suggested that although specific technologies will change, will continue to evolve, cross-functional skills are here to stay. And that does give us some comfort because it does give us kind of a place to start. But it does tell us that focusing on technology alone is not going to get our students to where they need to be. So as educators, if we're worrying about, whether or not to bring this technology or that technology into the classroom, whether it's Mindstorms or Spike Prime or some other robotic platform, whether it's Python or Java, that really isn't as important as building these cross-functional skills. And frankly, there are, of course, many ways to build these cross-functional skills. You can do it through sport, through debate, through other activities that exist in your schools. But we happen to believe, through our experience, that robotics, and in particular competitive robotics, allows our students to not only learn the tech, but also build some of these other softer skills at the same time. Next slide. So I'm sure you guys as educators have thought about all of this before. Perhaps you have strong opinions about this topic one way or another, but what we can see is that as a country, and I hate to say this, Canada is really not performing very well as far as innovation. This is something called the Global Innovation Index. It comes out every year. It's essentially looking at many indicators across 136 countries to determine your level of innovation. Canada appeared on the top 10 in 2011, but since then hasn't appeared and currently is at number 17 or 18. And there are a lot of components that go into this, this GII. One of, I'll mention just 3 of them, but not as many kids, it seems, in Canada are choosing STEM careers relative to other countries, we found. Those graduating in engineering and computer science are leaving to go to the US for better prospects, better pay. I know I did. I graduated in electrical engineering from McMaster and immediately found a better paying job in Silicon Valley. And what we're finding also is that many of the kids in Canada that are choosing STEM in post-secondary and beyond are in many ways one-dimensional. In particular, we're looking at university admissions to engineering and computer science programs here in Canada. The requirements are very much science and math based. And they aren't really looking at the holistic kid as they are in the US or the UK, and if you look at this list, the USA is number 2 and the UK is number 4. But the bottom line is that we need to increase our ability to innovate. And we think that engaging in activities like robotics will help our students develop these cross-functional skills and allow them to become better innovators.
All right, so thanks, Samir. What we'd like to think about is what are some pain points that make it challenging to deliver a robotics program? What things are you struggling with, or do you find challenging? Maybe you don't, but what are things that are more difficult that that make it so that you can't initiate or deliver a robotics program at your school or at your school. So again, there's another code there, and that's even smaller. And I don't know where my glasses are. One 466-2487. 1-466-2487. So please share some pain points. I'm just going to unshare the screen quickly, and I'm going to go look at the first mentee we talked about. This is the first mentee. Some of the results coming through from that. So here's some of the pain points you mentioned. Availability of technology, school resources, funding space, teacher knowledge, collaboration, teacher experience, cost. I see cost and money could be combined there as well. Location, cost again, district support. So here's some areas that we've identified that are very similar to the group the topics you mentioned there. Thank you for your thoughts and ideas there. The curriculum, what is the starting point that we might have? Where do we go? What can we use to get going? One thing that we said, I didn't see that in the results that you shared, but what ages or maybe it was their age appropriate activities. The terminology and all the language that you use around robotics and STEM kind of vocabulary. Then which robot, do you want to start with? How many, you can look at those lists there and just see which ones that you may be aware of. I saw something about Lego Mindstorms, and we'll refer to Lego Spike Prime shortly here. Budget, again, for materials, budget for to take a course, budget to upgrade. So very similar to what we said, to what we identified too. Now the slides are not. Sorry. So a comment about curriculum and just taking a quick look at some of the areas. Yeah, I mean, because it's a STEM, or robotics is a STEM kind of concept, automatically you can be applying many different types of different subject areas in the curriculum. It's very interdisciplinary. That's what STEM stands for. It's an interdisciplinary kind of topic. And in the science curriculum in particular, there's all kinds of reference now to it talks about the digital world and being scientifically literate. Of course, that also means digitally literate nowadays. And then career options and possibilities in engineering and design technology. But all these areas, doesn't mean that it's just an engineering topic. It absolutely isn't. Robotics can be applied across many subject areas. The two main drop downs in the curriculum here with subject introduction. Sorry, that was the last one. This one, organizing ideas. In this sixth overarching theme here, computer science, it is expected that it's taught from K to 6. Other areas like space starts in grade 4 up to 6, but computing science is expected to be addressed through all those ages. And we want to connect you and say, hey, robotics is one of those ways that you could address that year by year if you chose to. And then looking at very specific computing science topics here on this slide. Sorry, this is the same slide here. We know that through robotics and especially in particular, probably competitive robotics, that they can gain the knowledge, understanding, skills, and procedures, and you could hit it all with one topic, one check mark here. So what can you do? What I have here, and we can share the slides with you and how that you have access to these. I typed in a topic of a letter to admin or leadership saying that we want to introduce robotics or have a robotics club or team. And I really love the response in there. You can take that letter and you can use it if you like. You can take parts out of it. You can add things, but it worded it quite well for me. Like I talked a lot about the skills that are important, how it extends beyond the classroom, opportunities, leadership, so many things that come from. I think that so many schools and school districts right now have a goal around STEM or a goal around computing science and how to implement that. And if you can find out those goals, I think that you could probably align with those, and that might lead to some budgetary. So you can also, we talked about polling the students and or parents. So I have two surveys here. In the poll to students, I know sometimes with young children, you have, the happy faces and different ways of asking questions to make it easy and engaging for them. But here's some basic questions. Do you want to use robots? Would you join a robotics club? Check any robots you have used. You could make that list even longer, or rating their coding skills. Do you like coding? Do you know what coding is? You could add. And then down at the bottom, I have some questions that are a little bit more geared towards older students, as well as a parent survey. So child interested in robotics, what they could learn. So you're welcome to take, if those help you, if you wanted to poll someone in your school, you're welcome to use either of those surveys and modify it to your needs. I'm not going to go over all of these because we really want to focus on getting you to, well, what can I start with? What program do I use? What kits do I use? And we have a suggestion here that will really help you. We're big fans of the FIRST Robotics platform, and we want to share more about the robotics course with you. Samir?
Thanks, Ryan. So like Ryan said, we are big fans of the FIRST platform. All three of us have been involved with FIRST for many years. I started off as the FIRST LEGO League mentor, and then ultimately a referee, and then a judge about 8 years ago. Chris has been involved in FIRST from at the FTC levels, Ryan as well. We'll talk about what that is in a second. But first of all the platforms that we have looked at, and Ryan in his class has used Sphero and some of these other platforms. First of all the platforms that we've used is the only one that has developed these or conducted these longitudinal randomized trials around the efficacy of their program. And so they're very serious about demonstrating how their programs are effective. And so, this is their results, not mine. But I think we see this in practice when we're looking at the teams that we've been involved with here in Calgary. 81% of alumni choose STEM over the comparison group of 58%. And then over 2 times the number of people choosing, or kids choosing engineering or computer science over the control group. Next slide. Which is great, right? But more importantly, FIRST is looking at all of those other cross-functional skills. And in particular, these are some of the results that they've noticed. And again, the three of us concur with this. 90% increase in communication, conflict resolution, 93%, time management, 95%, problem solving. Some of these key skill areas were mentioned in the mentee that you guys put together. So that was great to see. But we're definitely seeing this in practice. And it's one of the many reasons why we are very much in line with what FIRST is doing.
So building on what Samir was talking about, what is FIRST? FIRST is a global robotics competition for students. The idea is to fuse robotics with a competitive atmosphere to help students grow their skills in a fun, interactive way. FIRST offers a number of different levels, stemming from kindergarten all the way up to high school. The idea behind FIRST is students work on a team to build and design a robot to compete in a new challenge yearly. The idea is by having teams build a robot in a competitive atmosphere, students can gain the soft skills that they need to prepare for the future in a fun way. So the first program we'll touch on is FIRST LEGO League. This is a program that's focused on LEGO robotics and aimed at elementary and junior high students. Teams work together to design and compete on a variety of challenges. Teams compete against the clock in a competitive atmosphere to try and get as many points by completing different challenges. FTC is the next step up, which is FIRST Tech Challenge. This is aimed at high school and junior high kids. Similar to FLL, teams work together to build and design a robot, but unlike FLL, you actually work with an alliance partner, so you get that collaboration piece in there and compete against another alliance to try and score the most points. This is the next step up. So this isn't using Lego anymore. This is more custom manufacturing and different more advanced robotics kits. These robots are bigger, about a foot cubed, and take place on a 12 by 12 field, the gameplay. And the final level is FRC, First Robotics Competition. This is very similar to FTC, but this is aimed directly at high school kids. This is just at, again, a larger scale. So this takes place on a basketball court-sized field where there's 3 robots competing against each other. And with all these programs, the idea is to get kids involved in STEM, creative thinking, problem solving through a robotics competition. Next slide, Ryan. So today we'll mainly focus on FLL, and here we'll play a short video just talking about what FLL is and showing some highlights from past events.
My favorite thing about First LEGO League is the teamwork. Probably being with my friends. And we get to make their way, and that's my favorite part. I get to play Legos and they're the field.
First LEGO League is one of 3 engaging FIRST programs. Participants gain real-world problem-solving experiences through a guided global robotics program, helping today's students and teachers build a better future together.
First LEGO League introduces STEM to children ages 4 to 16 to inspire young people to experiment and grow their critical thinking, coding, and design skills through hands-on STEM learning and robotics.
First LEGO League is fun. Students can't wait for this part of the day. They're teaching inclusion, teamwork, how to be creative, and think outside the box.
Children can join at any division based on their age or grade level. First LEGO League Discover is a playful introductory STEM program that ignites students' natural curiosity and builds their habits of learning with hands-on activities in the classroom and at home using Lego Duplo bricks.
I built a supermarket. I built a fire station, and I even put a kitchen so the firefighters don't get hungry. We built all kinds of stuff that we could help our community.
In First LEGO League Explore, students focus on the fundamentals of engineering. Students explore a real-world scientific concept, build a model, and code it to make it move using LEGO education technology.
They are able to do a lot of learning through play. All of a sudden, the students will have those aha moments.
Sounds like, oh, I know how they build robots now. When it works, I'm really happy. Because we worked really hard. You can share ideas and build off of other people's ideas.
It's just like really cool and like so cute to see them being all excited and happy. I feel like when you're young and you find that, they're like follow you along as you grow, and so that keeps you motivated to do something.
Friendly competition is at the heart of First LEGO League Challenge. As teams of students ages 9 to 16 engage in research, problem solving, coding, and engineering.
Our students are creating something new every single year, and they're learning about all of these things that you would never see in a traditional classroom or curriculum.
First LEGO League Challenge has 3 components: the core values, the robot game, and the innovation project, where you're able to solve a real world problem.
First LEGO League is about more than robots. It's about solving problems that are bigger than they ever imagined, thinking outside the box, and being excited to be part of the team.
I am first.
Feels like first.
First is my family.
First is the best thing you could do. First is discovery, innovation, impact.
Conclusion.
You're right. I
So what we'll focus on today here is FLL Challenge. So that is actually the competitive part of the first LEGO League. And that, as they mentioned in the video, sort of breaks down into 4 different core concepts. The cool thing with the FLL Challenge, you actually get to participate in live events. So you get to put your skills to the test, you get to build, design throughout the year, and then actually go into a real life competition where you actually get to put everything you work towards on the table and share and collaborate with other teams. So some of the core areas of FLL are robot design. So you need to identify your mission strategy, design your robot and program to create an effective plan, create your robot code and solution, and then you actually have to communicate this. You actually communicate this to a panel of judges, your design process and what you've done. Another key concept is the robot game. So you take part in a 2.5-minute game where you try and complete a number of missions and tasks. Next slide, Ryan. Another cool part of the FLL program is the innovation project. So each year, there's an overall theme to FIRST, and they're always relevant topics such as energy, space exploration, hydrogen, all buzzwords. And you actually get to identify a problem in these areas and come up with a solution and share these ideas. So you get to use your creative bones and design and communication to share these ideas with other people. And another key factor of FIRST is its core values. In the competition, they actually judge you on how you're living up to these core values, applying your teamwork skills, your innovation skills, and how you're being inclusive and impactful. Next slide. So to give you an idea of sort of how the gameplay works, we'll play this short video here. Ryan, if you want to start it. Can you mute it, Ryan? So teams are given 2.5 minutes during a match, and the matches take place on a dining room sized table with a game mat and challenge set. Each year, FLL has a set of game rules which students need to consider when building and designing their robot. The cool thing about FIRST, these get updated yearly, so you get new challenges to look at each year. There's a large number of challenges to complete during a match. Teams don't need to complete all these challenges. They need to use their time management skills to score as many points as possible and focus on the challenges where their robot is reliable. The cool part about FLL, which makes it different than other FIRST programs, they actually have a modular robot. As you can see in the video there, they actually swapped out components mid-match. Just a unique feature that allows you to be creative, and actually you have to be design oriented to try and come up with a robot that's actually modular. Finally, the robot is fully pre-programmed and runs autonomously. So it takes a lot of preparation and practice to go into perfecting your robot. Let's jump to the next slide, Ryan.
It has to, sorry, Chris. Yeah.
Oh, you're all good. So to start an FLL team, you need a few physical resources, those being a game set and gameplay map, which were shown in that video there. These are updated yearly, but you also need a robot kit. And a great kit to get started with is the LEGO Spike Prime kit. This is the latest and greatest kit from LEGO and allows you to easily make a robot that's modular and easy to prototype and play with. The kits come with a number of sensors and actuators, along with a robotic hub that makes it easy to use and pretty intuitive. The Spike Prime kit also has a computer-based programming software that allows you to use block coding, which is very intuitive and easy to use. Next slide. With these Spike Prime kits, the sky's the limit. So you can do something as complicated as balancing a robot on 2 wheels. Just think of an inverted pendulum where you're balancing a pencil on your finger. You can actually do this advanced stuff with a Spike Prime kit. You can also solve a Rubik's Cube. Some students designed and built a Rubik's Cube solver out of Spike Prime Lego. So really the sky's the limit, but the great part with this set is you can start with a simple things. You can start with just using a sensor, interaction with the sensor, figuring out how it works. Next slide. So apart from FLL, So apart from FLL, Lego Robotics can be used directly in the classroom to teach STEM skills to students. You can come up with small challenges that can utilize Lego Robotics to have students start looking at programming, mechanical design, and so many other things. So for example, I just came up with an idea here. Just a simple challenge: drive towards a bubbly can and grab a watermelon bubbly. So you can actually use all the concepts of robotics. So you have your sense, think, and act. So first you got sense. How can I actually sense the cans in front of me? Play the video there, Ryan. So in this case, we're using a sensor to actually push against the can to determine it's there. But the cool part about this, there's many solutions. If you jump to the next slide, Ryan. Play the video. You can use a different sensor. Instead of a force sensor, I can use a distance sensor. You can see here the robot will actually stop before the can. So really the sky's the limit, and creativity and problem solving can be utilized through these robotics kits and help teach kids those core fundamental things about STEM. So for the sake of time, we'll jump down a few slides and I'll pass it off to Samir to talk about how you can actually get the skills needed to bring robotics into your classroom.
Excuse me, Chris. Carol has her hand up. I'm just wondering if you would like to answer a question now, or if you'd rather wait till the end.
Let's let Samir run through, just in the sake of time, because we can stick around after as well to answer more questions.
So as I mentioned, Chris, Ryan, and I have been involved with FIRST for a while. We don't work for FIRST. We don't work for Lego. I know it may have seemed that way from some of the videos that you saw there. We aren't advertising for them, but we have been staunch believers in what FIRST has been doing. And when we started to get involved with FIRST as mentors many years ago, we really had to search for information, and if you Google FIRST robotics, many of you probably have looked at the FIRST kit. Someone has mentioned that they've done Mindstorms, worked with Mindstorms before. There is a lot of information on the internet, and I think that the challenge is really trying to figure out what's relevant, what's not relevant, and to kind of sift through all of that and actually know where you should focus your attention. So that's one of the reasons we started the robotics course, the three of us, because we realized that there really needed to be kind of an A to Z platform that took anybody, teachers, parents, that kind of took them from the basics to some of the advanced knowledge that you would need to run a robotics team, or even to bring it into your classroom. Next slide. So who is this course for? We wanted, if you're someone that wants to introduce creative thinking and problem solving in your classroom, if you believe, like we do, that robotics is an engaging way to teach new concepts in this new curriculum, I think one of the things that we would like to reinforce is that even though it says computer science in many of the, in many of the areas there on the curriculum, computer science is not necessarily just coding. And I think that's a misnomer that a lot of educators have personally. With robotics, you get the coding piece, but you also, it becomes more interesting because you're actually writing code that does something physically that you can engage with. And so, if you're someone that wants to bring a more engaging way to teach these computer science concepts, then robotics is definitely the way to go. You don't have time to go, as we did early on, from website to website and sift through hours of online content without knowing what you're looking at is relevant. And then if you want access to mentors like us with decades of experience collectively, kind of guiding you from A to Z. Next slide. So we ran this course last year for 9 educators in Calgary. And for 3 months, from June to the end of August. And these are just a couple of the testimonials. And these two particular teachers, I didn't use their last name, just in the interest of their privacy. But Emily, the first teacher that's mentioned there, she had worked with Lego Robotics before. She signed up for our course, and then she, as she says here, drastically improved her understanding of Lego Robotics, and has now signed up for the FTC course that we're offering also in the summer. And then Nicola, she had a team of 3 from her school that joined us for an FTC course that we had developed a kind of a draft for it. So they went through that. And there's a lot of material in the FTC course. It's not using Lego, as Chris said, it's using real components. So there's a lot more information that has to be learned. But because we laid it all out for them and we made it really easy for them to understand, they actually found that they could get through the material pretty easily. We focused on these 2 teachers because, interestingly enough, Emily won the first Lego League Mentor of the Year award this year in Calgary. And Nicola won the FTC Mentor of the Year award in Calgary. And both of them attribute their success and their team success to having started with the robotics course. So we think great kind of testimonials for what we've kind of built here. This is what the course looks like. We've got 5 modules. Robot 101 is really just kind of the basics of robotics that will, all the terminology, all the concepts that you may have heard of. We're going to explain all of that. Module 2 is where we get into some of the more strategic thinking of how to teach robotics in the classroom. Visual thinking, was it, Ryan? Was the sorry?
No, I'm sorry, visible thinking routines.
Visible thinking routines. Ryan worked extensively on that particular module. Module 3, Lego Robotics, probably the largest module. And if we get a chance here, I can show you some of this live. I know we're out of time here, so I'm trying to rush through the rest of these slides. But Lego Robotics, again, we're just taking it from the very basics all the way up to some more substantial Lego Robotics builds. And then once you're ready, we also have separated out the competitive robotics, because not everyone's interested in building and mentoring a robotics team. So if and when you're ready for that, then there's a separate section on how to build a competitive robotics team, and we'll take you through first and how that all works. And then finally, module 5 really dives a lot deeper than the other modules do in terms of the technology. So if you are a bit of a geek, like some of us are, that's really where you'll find a lot of the deep science behind a lot of the material covered in the other modules. How are we doing for time, Cheryl?
Well, it's 4:48, and
Okay.
so if you want to kind of wrap up, you're welcome to stay a little bit longer for questions if people have particular things. I can see that Chris is answering some questions in the chat, which is great.
Okay.
And well, I'll leave it up to you.
Okay, well, let me, if you guys are still interested, I can show you what the course looks like just very quickly. I'm going to share my screen here if I could. Yeah. Okay. So this is the designers, the course designers view. So this is not what you'd be looking at. You wouldn't see all these menu items here. But basically, we've got the 5 modules I mentioned. Last year we had a discussion group where, as a cohort, you can come together and ask each other questions, ask us questions. We're always on that discussion platform, kind of helping guide the learners. I'll jump right into the Lego robotics piece, because you can see it's one of the bigger ones with 22 different lessons. Let's just jump in here. So we start off by just going through the history of Lego robotics. We've got a lot of links here to other resources out on the internet that we've curated. Mainly because there is a lot of great information out there and we didn't want to reinvent the wheel. So this is really, we brought a lot of the good content under one umbrella, and then have kind of guided you or are going to guide you step by step going through all that content. All of the modules are set up with, in 3 ways: mechanical design, electrical design, programming. When we think about robotics, it's analogous to the human body for us. So mechanical design are the body parts. Electrical design is the nervous system that's communicating with all the body parts. And then programming is the brain. And so we kind of, all the modules are kind of set up that way. We have checkpoints along the way to test various learning. We get into very specific information about the structure, in this case of Lego, and how, when you would use certain parts and when you would not use certain parts. And then we have designed this base robot called the TRC, the Robotics Course Robot. And so we provide you instructions to actually build this after you've gone through all of the learning. And you can kind of see here, I'm not sure if it's showing up. Yeah, there we go. That once you've built this, you can start then using that. You use that to go through programming tutorials. So maybe some of what Chris was showing to you guys look like magic, but we step you through, step by step, lesson by lesson, showing you in this case in lesson 1 how to move a robot forward. We've got interactive, like animated video here that shows you how to code it using the block coding options available within Spike Prime. And then, by the end of this, in lesson 17, you would have a robot that would be making decisions and navigating an obstacle course. The other thing that we are offering through the course is this capstone challenge. We wanted to kind of bring all the learning that we're providing in a capstone challenge, where we're asking you to do a specific challenge and then submit the code to us, and then we'll critique it and give you feedback on that. So that's the course in a nutshell. I'm sorry that the demo here was shortchanged. Could you go back to the slides?
Yeah, you can either share your slides, Chris, or Samir, or you can stop. You want me to go back there?
Please, yeah. So I think we'll just leave you with one call to action. Can you click the button? So we are signing up a new cohort starting June 1st, cohort number 2. If you're interested, please go to this website and follow these instructions to sign up. If you are still thinking about it, please email us, get in touch with us. We're happy to chat with you about where you're at in your robotics education journey and try and figure out where we can kind of fit you in and how we can help you. Next click, Ryan. Normally we charge $247 for the course, but for the handful of you that are on this webinar, we're going to offer a promotion to take $100 off using this promo code until May 14th. And then the next click, Ryan. What we agreed to just before this call is that if you folks are able to sign up 2 learners that aren't present here, then we'll offer the course to you for absolutely free. And so again, the cohort starts in June. It runs for 3 months until August 31st. Last year, we also did a in-person workshop in late August where we brought all the learners into a build space. One reason was to solidify a lot of the learning that you would have done asynchronously, but then also to further challenge you with more difficult challenges. And we found that in-person workshop really helped. That's optional, so that really depends on how many learners want to do that, and we can kind of organize that at a later date. But that's it. We'll leave it there. Thank you very much for your time today. We're happy to kind of stick around for as long as we need to answer questions.
Thank you very much, Samir and Chris and Ryan. I can attest to the fun and learning that happens with kids and the ways in which those skills transfer to other areas. And I like the way that you were able to really show how those competencies are necessary in all parts of their lives. So, and thanks for sharing this, like Brad said, like a wild deal. I love it.
Thanks,
Good opportunities for further learning. Thanks for sharing.
Well, you're welcome. We're really trying to expand as widely as possible what we've put together here. This is just, hopefully it goes to show how much we believe in what we're doing.
Thank you. All right,
And
I will
if you
stop
want
the
to,
recording unless anyone has any questions that you would like for the whole group to hear. Carol, do you want to talk? Yeah, go ahead.
Yeah, I had a couple of questions. So my first question is, does the platform for programming run on Chromebooks or only on laptops?
We had one learner last year who was running it on her Chromebook, although I have not personally run it on a Chromebook. I've seen it being run. So my assumption is that it does, but I'd have to check to be 100% sure.
Yeah, we're a Chromebook only school. We have no laptops, which is the issue I ran into with Mindstorms this year, and had to do a workaround for that, but it's working okay. Second question is the course asynchronous, or like, do you have to, like, are you working together with other people, or can you do it at your own speed?
Yeah, so you can do it at your own speed. You can kind of jump around as you want. We do recommend you kind of go from within a module, you go from the top to the bottom, because we've designed it so that each piece builds on the piece before it. But as you go, if you've got questions, the platform allows you to ask questions right there where you've got an issue, and then we'll see that and we can answer it right there. So that's something that not all the other learners will see. That's just a conversation between us and the learner. But then that's why we set up a separate discussion group where if there are things that you want to ask that you think might be relevant to other people, we can definitely just answer some of those questions there. Everyone gets to see it there, and then can contribute as and when they see fit.
And then I have another quick question about First Lego League. It was something I was looking into. We used to have a robotics competition up here, but COVID took that out. Is there a cost for the game set and play mat? And if so, approximately how much?
Yeah. So I have these numbers kind of fresh because we did this last year. Spectrum Educational supplies the Spike Prime kit. I think you can get it at Mind Toys or something. Mindless Toys. I can't remember the name of the store. What's that?
no, I'll find it. I know what you mean.
Okay. But it was about I think the price has gone up to $549 now, Canadian. But last year we were able to negotiate with Spectrum because we had 9 learners. They dropped the price to $450 for us. So that's something we would also consider trying to do this year.
Mastermind Toys.
Mastermind, that's it, not mindless.
Yeah.
And then the kit. So the challenge set was $295 US. They charge in US dollars. So whatever that comes out to be in Canadian, about 350, 400 bucks, let's say. And the challenge kit includes the mat as well as all the obstacles.
Thanks.
So we think like under $1,000, including even the registration fees. If you want a competitive team, the registration is also about $295. It was this past year.
How many kids do you typically have on a team?
I'll let Chris maybe or Ryan take that.
Chris.
Typically, it's in the range of 4 to 6. We find 6 is a good number. Since with that number, you at least get some collaboration as well, and everyone can find a job to do.
I guess my next question then is like, so when you do the First Lego League, like this year I ran a robotics for grades 2 on up, a robotics after school club, but I had the grades separated. But if I was to go into First Lego, do they, like the other competitions I've had been, there had to be in certain grades to belong to a team? Is that what First Lego League is like? Is there certain grades that have to be on a team, or does it matter?
No, it can be a range. They have to be within that certain range though. So for Lego League, a challenge, I believe it's grade 4 to 9. But you can have a variety. So with for example, I do FTC a lot, and we have kids as young as grade 7 all the way to grade 12 on the same team. And it actually works well because you actually get that mentoring skill as well when you have that age range, and kids can learn from each other too, which is a cool experience.
One challenge we had with one of the learners this year is she went back to her school and basically had an orientation event where she was inviting students to show interest. I think, Chris, we had told her that an FTC team would be about 6 students. She had 50 students show up. And so the challenge for her was really, how do I now, pare this down? But that was a signal to the school that they needed to actually go and dedicate more resources to more teams. So I think this year they're going to have 3 teams in the next season.
Yeah, this year we gave our junior high students a choice of 3rd term options, and all the boys chose robotics. So I have every junior high boy except for one in robotics this term.
Yeah, that kind of opens up another can of worms. We were very specific last year where we only took female learners because we have found through our experience that when you have female mentors, robotics mentors, that's when the girls tend to show up. So Calgary Girls School was that school that had that problem of 50 girls showing up, actually, which was a nice problem to see.
Any other questions? Inquiries?
Okay, thank you so much. Thank you, Carol. Thank you, everyone, for coming. Thank you, Samir and Chris and Ryan, for putting your presentation together and sharing your wisdom and expertise and experience in terms of how this you can make this come alive for students. And so I hope you'll get lots of people signing up for the course. And thanks for sharing with us today.
Thanks, Cheryl, for organizing.